Okay, I promised you on Monday a video for solving quadratic equations, but then I wasn't there Wednesday because my dad got ill suddenly. So this is kind of the promised video. So if you had trouble with Monday night's homework, then you might want to watch this video and then go try it again. Okay, so I'm going to pull up PowerPoint again and talk about solving quadratic equations. I'm going to kind of talk you through it. All right, so this is sort of, you have some stuff like this already in your notes, but this might give you more, it might be helpful. All right, if you want to solve quadratic equations, the first thing you do is you put everything on one side of the equation and you have 0 on the other side. So we talked about that on Monday. Now, sometimes when you start moving things around, you can simplify it a little bit. You might be able to combine some numbers or combine some variables. So that's why it says simplify if possible. Then anytime you're doing, you're solving a quadratic equation, really any polynomial equation, always look and see if there are any terms you can factor out. Now, sometimes there are and sometimes there aren't, but it makes your life easier if there's a common term if you pull it out. So I always do that first. Then finish factoring. Sometimes when you pull the common term out, that's all you can do. But sometimes after you pull the common term out, there's something else to do. So make sure that you factor the thing completely. And then you're going to have several factors equal 0. So remember, you set each one of those factors equal to 0 and then solve it. Okay? So you got some examples in your notes, but let's go look at a few more examples. All right, look at this one. All right. 6x squared equals 3x. So everything's got to be on one side of the equation. All right, so I decided just to arbitrarily put everything on the left side and have 0 on the right side. So how did I do that? Well, remember, how would I get rid of that 3x? I'd have to subtract 3x on this side, and then I would have to subtract 3x on that side. Well, 3x minus 3x goes out and leaves me 0, and so that's where I got 6x squared minus 3x. So now everything's on one side and 0's on the other side. Now, do those have anything in common? Do you see that a 3 can be pulled out and an x can be pulled out? So I pulled the 3x out. Now, like I told you in class on Monday, I think better in multiplication than I do division. So I think, what do I multiply 3x by to get 6x squared? Well, I need to multiply the 3 by the 2 to get the 6. I need to multiply x by another x to get the x squared. So I would need to use a 2x, and then minus and minus. What do you multiply 3x by to leave it 3x? Don't you multiply by 1? So that says that one number times another number 0. So remember what we said, when you multiply two numbers and the answer is 0, one of those numbers must have been 0. So either 3x is 0, that first factor, or, not and, 2x minus 1 is 0. And then I just solved those little linear equations. So I got rid of the 3 by dividing, and so 0 divided by 3 is 0. So the solution of this one is 0. To get rid of that minus 1, I added 1 to both sides. So that left me 2x, and I combined that and got 2x is 1. So to get rid of the 2, I divided by 2, so I got x to be a half. So this one actually has two answers. 0 would work, and sure enough, 0 squared is 0. If you plug 0 in this side, you get 0. If you plug 0 in that side, you get 0. All right. If you plug a half in this side, 3 times a half is 3 halves. If you plug a half in there and you square it, you get a fourth. And 6 times 1/4, 6 times 1 is 6, and 1 times 4 is 4, and 6/4 reduces to 3 halves, so it would check. Okay? Now, what if you had a problem like this? 2x squared equals 19x plus 33. Again, I moved everything, so I subtracted 19x from both sides, and I subtracted 33 from both sides, and got everything on the left side and 0 on the right side. Now this time there's nothing to factor out. They don't have anything in common. So again, you can factor it any way you want to. I just did trial and error, like we talked about last Friday. So how do you get 2x squared? Well, the 2x and an x. Now that's a minus. So I knew there was one of each. So one of these had a plus and one had a minus. Now, it could have been the minus is here and the plus is here. I didn't know. I just tried one to see if it worked and got lucky. All right. I wrote down the factors of 33, 1 and 33 and 3 and 11. And I'm trying to get a minus 19. So first I tried the 11 there and the 3 there, okay? Now I didn't try the 1 and the 33 because those numbers seem real big. I didn't think they'd give me a 19. So I just decided to try that pair first. I just had to pick one to try, so I arbitrarily tried that pair first. It might not have worked. If those hadn't worked, then I'd have gone back and tried the 1 and the 33, okay? But look what happens. 2x times x is 2x squared. Well, 2x times that minus 3 is a minus 6x. Then when I did the 11 times the x, I got 11x, and then 11 times this minus 3 gives me a minus 33. But this minus 6 plus what? 11 gives me a positive 5, and see, that's not going to work for me. Okay? So now I said, well, what if I switch the numbers? What if I put the 3 there and the 11 there? Well, I still get the 2x squared, but this time I get a minus 22x and a plus 3x. And look, minus 22 plus 3, remember when the signs are different, you subtract, gives me a negative 19, and that's what I needed. So this ended up being the one that was right. So then either this one is 0 or the second one's 0, and I just solved it. When I added 11 to both sides, I got 11 for this one. I subtracted 3 from both sides and got 2x would be a negative 3, then divided both sides by 2 and got x to be a negative 3/2. So again, this answer works or that answer works, okay? So sometimes with quadratics, you get 2 different answers, okay? Now, let's look at another one. All right, look at this one. All right, here's my next example. Now again, everything has to be on one side and 0 on the other side. So because it doesn't make any difference, in other words, I just decided to go to the other side just to show you that you could do that if you wanted to. I could have put the negative 3, I could have added 3 to both sides and had 12x minus 9x squared plus 3 on this side. Why did I decide to go to this side? Well, most of you get nervous when the coefficient of your squared term is negative. So I added 9x squared to both sides. All right, so I've got to add a 9x squared over here. And then to get rid of the 12x, I'd have to subtract a 12x over here. So I had to subtract a 12x over here. So that's why everything went away on this side, and that's what I have on that side. Remember, always look for a common factor first. You see that 3 is a factor of all of those, so I pulled a 3 out. See, 3 times 3 is the 9, 3 times 4 is the 12, 3 times 1 is the 3. Now, this one, I tried by trial and error, and I couldn't get it to work. So I decided to go use the quadratic formula. Now, let me show you something about the quadratic formula that's pretty sweet. If you have to go use the quadratic formula, what ends up happening is the 2 things that come out are your answers. You don't have to really go and do all of this if you're using the quadratic formula. Remember, A is your number in front of your squared term, B is your number in front of your x, so it's a negative 4, and C is your number, so negative 1. So the opposite of B, since this was a negative 4, my opposite would be a positive 4. Then I put negative 4 in for B, but I've got to square it. That's how I got 16. And it's minus 4. My A was 3, and my C was a negative 1. But see, minus this negative, so that makes it a plus 12. Okay? So I ended up getting a 28 right here. Now, if you remember, we talked about this earlier in the semester. If you don't know how to simplify the square root of 28, go make a factor tree, 4 times 7, and keep breaking it down until everything's prime. So I replaced my 28 with this 2 and this 2 and this 7. And then remember, when you have a pair that match, you bring them out. You write down what's in the circle only once. So the square root of 28 is the same thing as 2 the square root of 7. So I replaced the square root of 28 with 2 the square root of 7. And I noticed I could factor a 2 out on the top, and I could factor a 2 out on the bottom. All right? And those divided out and left me 2 plus or minus the square root of 7 over 3. So I've got 2 answers. I've got 2 plus the square root of 7 over 3, and I've got 2 minus the square root of 7 over 3. That's my answers. Now remember, we talked about if you're going to factor, it's with quadratic formula, it's always minus and minus. So I showed you if I went ahead and did it this way, I'd get the same answer. So one of those numbers got slid in here behind this minus, and the other answer got slid in here behind that minus. All right, so either one of those three numbers has to be 0. Well, 3 is never going to be 0, so that doesn't work. Or x minus this thing could be 0, or x minus that thing could be 0. Now, how would you get rid of that nasty thing? Wouldn't you have to add it to both sides? So see, those would go out and you'd have x equals that thing. So when you're doing the quadratic formula, those are your answers. So it makes life a little bit easier when you've got when you use the quadratic formula with a quadratic equation. The answers just fall out of that quadratic formula. Okay, look at this one. All right, I moved everything to one side. All right, I factored out my 4. And so I ended up, now there's two ways to do this. The short way is to realize that you've got the difference of perfect squares, like that a squared minus that b squared. You got something squared minus something squared. Well, what do you square to get x squared? Don't you square x? Well, what do you square to get 3? Don't you square the square root of 3? All right, so that would be this one minus that one, see, times that one plus that one. That's that formula that's got a squared minus b squared in it that we went over in class. So if you know that formula, you can do it real fast. Well, what if you don't know the formula? Well, if you don't know the formula, we kind of clear that. If you don't know the formula, then when you get right here, and you decide you want to use the quadratic formula, remember it would be like x minus and x minus. So look what happens over here. Remember what happens. You got x squared minus 3 right here. That's what I'm trying to use the quadratic formula on. So what's in front of my square term is my a, so that's a 1. Now notice, I didn't have any x's. I had 0 x's. So 0 times x is 0. I had none. So the b would be 0 and c would be negative 3. Now, the opposite of 0 is still 0. Okay? Plus or minus, you'd have to square your 0 minus 4. Your a is 1 and your c is a negative 3. But notice what happens. Minus this negative is a plus, and 0 squared is 0. So 0 plus 12 is 12. So again, I did my factor tree to kind of simplify this and broke 12 down into 2 times 2 times 3. So I could circle a pair of 2's and bring them out. So the square root of 12 is 2 times the square root of 3. All right. Now, I've got a 0 here, but 0 plus or minus 2 the square root of 3 is just plus or minus 2 the square root of 3. And those 2's went out and just left me plus or minus the square root of 3. So x is either square root of 3 or x is a negative square root of 3. All right, so I can put a square root of 3, or I can put a negative square root of 3. But what's the same thing as minus a negative? Isn't that plus a positive? So when I factor with the quadratic formula, I get the same thing. Well, this one, 4 can't be 0. When I get this one, I added the square root of 3 to both sides and got the square root of 3. To get this one, I subtracted the square root of 3 from both sides, so I get 2 answers. Okay? So you can factor them any way that's legal that you want to. All right, let's look at one more and then we'll be done. Okay, look at this one to make a point. This one I tried by trial and error, and again, I couldn't get it to work. All right, so I tried the quadratic formula. So my a is 2, and this negative, that minus 5, that's my b, and this plus 5, that's my c. So I substituted in. If b is a negative 5, then the opposite of b would be a positive 5. I squared my negative 5 and got 25. My a is 2, and my c is 5. Well, 4 times 2 is 8, and 8 times 5 is 40. Now look what happens that's really weird. 25 minus 40 is a negative 15. Now, you can't take the square root of a negative number and get a real number answer. There's nothing you can multiply by itself that's going to give you a negative, because a positive times a positive is a positive, and a negative times a negative is a positive. You can't multiply two like things and get a negative, Because for you to get a negative, one would have to be positive and one would have to be negative. So there's no answer to this. So the answer to this would be no real solution, no answer. In other words, there is no number that you can plug in for X and make this sentence be true. You can't plug in a 1/2 or a -7 or the square root of 3, nothing that you can put in for X will make this true. So if you get the square root of a negative number, that means this doesn't have any solutions, all right? So I hope if that bothered you before, that that's a little bit better, okay? So what I'm going to do is, I'm going to stop and I'm going to do this. So if you had trouble with your homework on Monday night, then maybe go back and retry it and see if